Oh yeah, man. Uncles and nephews, aunties and nieces. The boy is back with another video. And depending on when I upload this, it may be a long time. It may be right after the third video or whatever video was previous to this. But anyways, we back with another video. We recording. So this video is going to be about all. Let me move my mic closer because this is a big one. This is a big one, ladies and gentlemen. This one is all about NLP, and NLP stands for Natural Language Processor. So this concept is fairly prevalent throughout the world of data science and computer engineering. It basically is essentially sentiment analysis. So all those reviews that you see on Yelp or Google about restaurants, all the reviews you see on on Auto Trader or Cars.com about cars, yeah, that's what NLP does. NLP can take those and create basically if the car is good or bad, if the restaurant's good or bad, etc., etc. So I decided to incorporate this in my projects just to showcase that I can understand it and I can do it based on my very limited knowledge, mind you, because I just learned the full concept and got the grasp of the full concept about a week ago. All right, so basically we're just gonna go through the file as always and just talk you guys through it and kind of explain things because I feel like some people don't really know what NLP means. I thought NLP was like a specific model, but no, you can use any type of model for natural language processing. It's just like a umbrella topic almost. So obviously you started off importing all your imports. There's a lot here because I got some from various sites, from various sources, just to see if I could run it on my machine, and then I tried to apply it to obviously my Spotify project. So some of the packages I do want to point out, or classes I do want to point out: TD IDF Vectorizer. We'll explain that in a second. Count Vectorizer, Text Blob from the Text Blob package, Stop Words from the Stop Words package, RE, which is I want to say regex, which is kind of like the pattern in certain words. I'll explain that. Naive Bayes classifier. NLTK corpus, which is kind of where I got the stop words from, which is I'll explain in a minute. So those are basically the ones I want to point out, the packages that you really do need. You need TDI vectorizer, you need SVC, you need count vectorizer, you need text blob, you need stop words, you need regex, you need tokenizer, you need naive Bayes classifier, and you also need NLTK corpus and NLTK corpus with stop words. Okay. And this is where I download the stop words. So stop words are essentially words that don't really have any value. So like a, and, the, but, those words that really don't have, like, you can't classify. It's not going to help with the classification, essentially. Those are the stop words are. So it's basically throwaway words, is what I like to call it. So going in, testing out different NLP functions, techniques, and models. So first up, we have the TD IDF vectorizer. So TDF IDF is basically term frequency inverse document frequency. Basically, it's how many times a word appears in a document and how helpful can it be to classify the document. So right here we have a corpus. A corpus is essentially just like a list or a paragraph or a sentence or song lyrics. Basically any group of words, any group of sentences, any group of paragraphs is called a corpus. So in this very simple example, we have a corpus, which is a list of three, we'll call them sentence fragments, right? And so what the vectorizer does is it vectorizes it and transforms it into numbers. Now, what these numbers mean is that it is how useful the word is going to be to classify. So, for example, let's see. So for 0, 1, that is this word right here. Is going to be 30, is going to be 0.34. It's kind of like a score between 0 and 1. So it's going to be 0.34 more helpful into classifying, if that makes any sense. So basically, these words are just listed and how helpful they are going to be to to classify. Sorry, my bad. So yeah. So basically, and this is when I get the features. So the features. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 features, and you see that these numbers go from 0 to 7, which is 8. So basically, these are the word. These numbers correspond to these words, and these numbers correspond to the index and the list. So if you do 0, 7, so 0 is this one, 7 is the word this, 0, 7 is going to be 0.58. So it's going to be kind of helpful. So 0.6 is going to be kind of helpful, kind of not. So that's how you would read this. So basically, this is just essentially data exploration, but in a textualized form and using text, which I've never done before. So this is actually very interesting to look into. And this is just another way to do it. So so IDF values can go past the 1. So normally the higher the score for the word, the more important the word is, better for classifying. And then with the IDF value, I'm not entirely sure. Let me look it up real quick. I'm not entirely sure. They only go to 1. And again, guys, if you don't understand it, like, oh, sorry. You guys just go look it up, man. There's plenty of resources. I do this stuff all the time, and I have a degree. So the reason why the TF-IDF value is between 0 and 1 is because it's a weight, essentially. IDF values aren't weights. They're just seeing how useful the word is for classifying. They're not weights in a model. TF, jeez. I'm just going to say TDFID, and that's going to be, yeah. So TDFID values are weights in a model. So that's why they have to be at between 1, because weights don't go over 1 in models. So this is just another example. I have obviously geeks for geeks, and then R2J, and obviously there's only really 3 words. 4, 1.2, and then RGJ. Now the reason why that geeks has a smaller IDF value than 4 and R2J. Can you guess why? Because if you look at it, it's pretty obvious. Geeks appears 3 times, R2J appears once, 4 appears once. Therefore, if we use 4 and R2J to classify, we're going to get higher accuracy. We're going to be more accurate. We're going to get a higher probability that we classify in the right class, because those 2 words only appear once, i.e., why they have the same IDF value. Same, and with geeks appears more, because you're not, if you give the word geeks the machine, the model's going to be like, okay, is it 1 or is it 2? Is it D0? Is it D1? Is it D0? Is it D1? So that's what it's going to, that's what we're going to do. So again, these are just alternate methods to get TDIEF values. Obviously, all these are 1 because geek 1, geek 2, geek 3, D4 only appear once. Cool. All right, so this is a more, I guess, better example of how this works. So text category. What is this? Hold on. Oh, okay. So this is when you have a text and a category, and you want to figure out what. Oh, this. I'm so sorry. I should probably label this. This is creating a bag of words. So a bag of words essentially is what a model uses to train itself. So this is taking a text from a data frame. This is a category A, category B, category C, with categories A, B, and C. So basically what it's doing, it's creating a bag of words. So in category A, in its text in this this is a horrible example now I look at it, but all these words are in all these categories. So category A, category B, category C. So yeah, it's just creating a bag of words essentially per category. It's just listing out which words are in which category. So here we have my attempt. So obviously, in importing the pickle file, and once again, I highly recommend pickle files for when you have to split your machine. Oh, finish. Sorry, I'm running something in the background, but obviously, pickle files are good for when you need to transfer a data set from one file to another. So we do that. And so for the bag of words, so for this project, I'm looking at title and genre because I want to predict the genre. So I do that. I subset it. Obviously, drop the duplicates, reset the index. So yeah, I try to do this method right here. This method right here in cells 18 to 25. Didn't work at all. Got this horrible mess because what I didn't realize is that there's a lot of ATL hip hop, and every single word that's in ATL hip hop has to be in that bag. So as you can see, there are a lot of rows and a lot of columns. Didn't want to do that. So we're gonna stop. We stop there. Yeah. I'm sure if I did a little bit of deeping, I could have finessed it. Maybe could have coded something to make it work. But no. This is, we're starting off at the base level. I just learned this last week. We're gonna go what we know, and we're gonna go what we see on these articles. Speaking of which, analytics video is so clutch. Has come in clutch for me for school, for personal projects. Go just type in analytics video. Go look at some of his stuff. I'm not sponsored by him. I don't know him. I don't know these people, this person, but he's so good. So this is the example of a corpus. That's what we're talking about. So basically it has sentences in each with a class, right? Training corpus, test corpus. Training for training the model, test for testing the model. So now, here's where I was kind of confused and where I had to reach out to some outside help. I thought that you could train parameters on an NLP model the same way you could train XGBoost, like just regression, ridge regression, voting classifier, etc. etc. You could use parameter grid search. You could use naive Bayes search. You could do that. Nope, can't do that. All your training, all your parameters is the text. So however clean your text is going in is how accurate your model is going to be. So if your text is clean, your model is going to be wildly accurate. If your text is dirty, it ain't going to be that accurate. So right here is a naive Bayes classifier, but I just pump in the training corpus. And this model is actually built on top of NLTK. And the person I reached out for with one of my coworkers said this is a good model to use when you're just starting out with natural language processing, which I am, so I used it. So basically, it's pretty easy. Obviously, takes the training corpus, does the little words, see which words are more likely to be in class A, class B, and then obviously classify these codes are amazing. Class A, I don't like the computer. Class B, cool. And accuracy is 83%. So I'm pretty confident that that is going to be belong in class A, and this is going to be in class B. So now what we have here is the probability. Cause I wanted to see, how probable is it? Like a 50-50? Is it like a 40? Is it a 55-45? Is it like a 60-40? And as you can see, it's about a 65 for this specific sentence. These computers are amazing, or their computers are amazing. The probability that's in class A is 65%. The probability of class that is in class B is 35%. So obviously it's going to lean towards class A, which is why if I did it, if I type this sentence in here, I get class A because it has the higher probability. Obviously easy stuff. Now, my application. I followed analytics videos, technique, code, and just applied it to my own thing. So obviously we have the word of bag. Word of bag. Cool. Basically all the song titles, all the genres. I subsetted it earlier. Obviously, for tuple, I just put for row, so it made a tuple. So dreams and nightmares, hip hop. So basically, split the data frame in two. Dreams and nightmare. Well, obviously, title of the song, genre, and it gave it in tuples, which is what I need to make the test train split. So what we have here is training data. Obviously, the tuple. The first one is the song name, and the second is the genre. Same with test data. Use the same model. Now, because there are so many different names of so many different songs that can fall into so many different genres, I was not expecting this to be high. In fact, 20% is probably what I expected, because again, this is a base model. This is built on top of NLTK. This is not like I'm not going in and using an XGBoost model to do this. I'm just using a base, naive Bayes classifier to do this. So obviously with the model, I just put Hot Guns, Atlanta Hip Hop. For a model that does 20%, I'm not gonna lie, that probably would be right. Just because I know Atlanta, and just because I know it probably is right. Love You Till I Die, hip hop. Again, not gonna lie, for a model that does 20% accuracy, I could probably understand that. I could probably get that. So here are the most informative features. So these are the features that are helpful. So number 2, the word bag, the name Chris, I'm assuming C Breezy, G and hot are the two most I guess are the 5 most informative features. I have absolutely no idea why. Do not ask me why. That is the way the model said. So yeah, I'm not entirely sure what the. Hold on, let me look it up actually. Yeah, I don't know why those are the 5 most informative. But hey, I ain't gonna argue the model. Just looking it up real quickly. Okay, so that didn't help at all. I do not know what these numbers mean. I will try and come back in a minute. Sorry, I'm just trying to give a quick explanation. Okay, so this is saying if it contains 2 bag, Chris, G, and hot, it all belongs to ATL Hip Hop. Is what I'm assuming. This is what it's saying. You know what? I'm dumb, because these are definitely values that say how informative it are. So all these are equally informative. Interesting. And they all just happen to be in an ATL Hip Hop. Huh. Interesting. Again, that's probably right. Like, Atlanta artists rename their songs anything these days. So what is this? The class of no. Oh, so this is another classification model from, again, the same guy, Analytics Video, this time using scikit-learn. So obviously training corpus, test corpus, you got to get the training data, training labels, test data, test labels, TD vectorizer, obviously, we explained what that is earlier. You got the test vectors, train vectors. Now, the model, this time, the model uses an SVM model, which is oh my gosh, I forgot the name. So I'm dumb. support vector machine model, which uses SVC. Yeah, guys, I may be smart. I don't remember any of the words. All right, support vector classifier. So the support vector machine uses support vector classifier with the kernel of linear. So the jeez. Yeah, I may know this stuff, but I promise you I use ChatGPT just as much as everybody because I don't remember. Yeah. Basically, it composes the dot product of the input vectors, and it's the linear transformation. It's expected to be linear. So if the relationship is linear, which song lyrics and song titles, not always linear, but for the most part, you can kind of guess. You can kind of guess what genre a song's going to fall into. Like, Dirt on My Boots, that's not a rap song. That's a country song. Love on Top, that's probably an R&B song, not a trap song. So it can be linear, and I just did it because it's the easiest one, but I'm probably in other models and other projects, and I'll probably play around with this one because this one I like more because I can actually play around with it, play the hyperparameters, and see if I can get the best value. So for this one, obviously nothing special, 50-50 because there's only 2 classes, and the accuracy is 50%. Again, because it's a hit or miss, it's literally a 50-50 shot. So my application of the support vector machine using the support vector classifier. So we have all my training data, testing data, train labels, test data, test labels, vectorizer, obviously, kernel, and we got an accuracy of about 19%. So at this point, I was like, okay, well, just from my base knowledge of natural language processing, I'm probably not going to get above 20. Now, with further experimentation and when I get further knowledge, I'm hoping to get above 20. But right now, the bar is set to the freaking ground right now, so there's nowhere to go with up. Speaking of up, I decided, you know what? This project can't end here. This project cannot end here. So for my last topic of this project, I decided to do song lyric sentiment analysis. Just seeing what songs mean, just seeing if they're subjective, is they're polarizing, and what's the overall tone of the song according to the machine. So I borrowed this. So the data set that I'm using for the lyrics is at this link right here. Go check it out. It's great. I'm not going to click on it now because, again, I ain't giving out free money over here. Here we have a couple of functions that I borrowed from my coworker from one of his projects that he said I could use. So get score gets the polarity of the score. So if the polarity is lower than 0, negative. If it's equal to 0, neutral. If it's bigger than 0, positive. Polarity gets the text blob. This whole thing is using text blob, the package text blob. And this get polarity, it returns the sentiment of the polarity. Now, polarity, I know what subjectivity is, but polarity, I believe, is something a little bit different, and it's not a traditional definition of polarity. Let's see. So polarity is basically sentiment. So, oh man, this is going to be hard to explain. I'm trying to think of a way to explain this. So polarity is like positive or negative words, like happy. So happy, sunshine, fun, smiles, ecstatic, exuberant. Those have positive polarity. They're on the happy side spectrum. Sad, depressed, thunderstorms, rain, sadness, anger, suffering. Those are negative polarity. So basically, that's the 2 ranges, and it goes from -1 to 1. -1 being negative, the positive 1 being positive. Subjectivity subjectivity is kind of more difficult because it's kind of like how the group of words trends towards a negative or a positive, if that makes any sense. Like, it really is hard to explain, like, what subjectivity is. It's like, it's not based in fact. It's based on like opinion and how they how they feel about a certain topic. It's really hard to explain. Like I was trying to explain it. It really is hard to explain. It basically refers to like, you know, personal opinions, personal judgments. Um, so almost 99% of songs are gonna be be subjective. So and this goes from a 0 to 1, where 1 is very subjective and 0 is not so subjective. And then I made my own sentiment analysis that just combines all these and gets the polarity, the subjectivity, the score, basically, you know, negative, neutral, positive, and then the length of the song, just because. So here we have the song "Irreplaceable" by the Queen Bee herself, Beyonce, and as you can see, the polarity is -0.1. So it's not positive, it's not really negative, but it's barely negative. It's kind of neutral, honestly. Subjectivity is 0.22, which honestly I'm surprised that is a little low because well, I mean, it's not really a breakup song. It's just kind of a song. It's kind of an anthem, I guess. So, I mean, I don't think she's really feeling her music the type of way. So, I'd say this is pretty good. Negative, yeah, because, I mean, irreplaceable. Like, take your, like, everything you own in the box and the couch, that's my stuff. If you, yes, I bought it, then don't touch it. All that talking a mess. Can you walk and touch? You know, like, it's not. It is negative, but she's not really, you know, feeling the word. Like you don't feel the stab in it. All right, so this is Usher, Usher baby. So you got it bad, man. Usher, king of R&B. So this is even slightly less polarizing. Still falling in that 0 range. Subjectivity, 50%, and I 100% because this is one of his hits. And yeah, no, he's feeling some type of way, or he's trying to make these people feel some type of way. I believe it, 100%. So the song has a negative score or whatever, which you gotta bet. I mean, if without getting too much into it, if you can't have what you want and you got it bad, and it will be negative for you. So yeah, and then again the length of the song. So obviously, Usher and Beyonce got something to say because the length of the song is pretty much the same. And so we have Dolly, the classic, highly honorable Dolly Parton. This is 9 to 5, which I actually used in the music video recently. Long story. But, so polarity is 0.6, or wow, 0.26. Subjectivity is 0.63. Yes. So, yes, I agree with this because polarity is more positive, you know, working 9 to 5, has an upbeat too in it. Subjectivity, yes, because never get the credit, enough to drive you crazy. 9 to 5, rich man's game. Yes, all she's feeling it because I think she wrote this. I don't know when she wrote this, but you know, I respect and I know that she's feeling words that she's singing. So she ain't got that much to say, you know, just a nice little bop, positive, upbeat, positive. So yeah, I agree. I agree with these findings for these songs. I really, really do. I really, really do. Um, yeah, so I guess that's really it on my first big project. I mean, I might add some more things, maybe a couple of graphs or something, but I did pretty much all the data exploration in other files. I did all the models in the other files, and this was the last thing I needed to do. So, yeah, first project of the new year done. Did it in about 4 months, 3.5, 4 months. We're on good pace. I guess for my first YouTube series, we're gonna see how it does. I'm gonna go back, you know, regain film because I always like to watch film and I work on my game in all facets. That's really what I do. Um, Gonna go back, look at the film, see if I can improve anything. Might decide to show my face. I don't know, depending on if the series goes well. Um, yeah, so I guess next up is my social media project, and I think that's gonna be very, very interesting because I'm interested to see if the data reflects what I think my social media presence is and what I actually watch on social media, save on social media, like on social media. So I'm interested to see I'm very interested to see about what happens. So that's probably gonna be my next project. I don't know when I'm gonna upload this video or that video or the next video or the next video, because I'm a very, very busy person and I like to stay very, very busy. And I suggest you stay busy too, because in this world, you got to stay busy because you got to make that money, baby. All right. Thank you guys for listening, and I will see you in the next video. Peace.